talked about intrusion detection system. By the way, before we start, I want to encourage you guys to make sure that you can fill out the Google form about the presentation time, because the presentation will starting from next Monday, and then the earlier for the first 3 days of presentation you get extra bonus. So the first day is already gone. I think there are two students they selected next Monday, and for those students they will get 15% bonus for their for presentation for this early presentation. And then for those who are there are still time slots available for the student for those who can set up who can present on next Thursday. You also get 10%. Okay, so we'll do that as quickly as possible. Okay. And the other thing is, on Thursday we'll have a written exam in class. And if you guys are for those who are on quarantine or you get COVID, don't worry. We'll give you guys a makeup exam, but the time will depend on how many students get quarantined or get COVID. So for those who cannot attempt, who cannot show up next Thursday, if you get COVID, let me know. I'll help you guys with the makeup exam. So don't worry about that. So this coming Thursday, we'll have a written exam in class. Okay, I'll be there, and then that will be a paper-based, and it's open book, open notes, but not open to computers, laptops, iPads, tablet computers, that kind of thing. Okay, so you guys can print out the related slides. Especially, we will focus on the cryptographic protocols. And for example, like Rabin, I usually will ask one question about Rabin, so make sure that you can understand those. Okay, then since there are a lot of related algorithms, formulas, so you guys can print those stuff. Okay, and also make sure that you guys understand the extended Euclidean algorithm, both on hand and with the both on hand and actually writing code. Okay, so there are two versions of that. Make sure that you guys can understand. So that's my tips. Okay, and so today will pretty much be the last lecture of this course. Okay, because on Thursday we'll have a written exam, and then next Monday there will be presentation. Okay, so we continue intrusion detection systems. So last time we talked about abnormal behavior signature. So a signature is a pattern that an intruder can that the intruder behave. So those signatures are important. We can find those signatures based on their audit log files, and then we can analyze them. Okay, based on both past data, and then we get find the patterns. Those are called signatures. And after that, we can parse packets to see whether the packets match any attack signatures. Okay. There are some examples of signatures. So, for example, we have LAN attack. So this is a particular type of DOS attack, and this attack is actually easy. So usually it's launched from somebody inside a network. So by an insider, they launch a DOS attack. Well, if the source and destination IP are the same, in some older systems, when they send this when they receive this type of packet, they kind of get trapped into an infinite loop. So a lot of the routers, they don't know how to deal with this because it will be an exception. So oftentimes it will actually cause an exception, and then the routers um, maybe turn off, okay, maybe reboot or something. So that's the LAN attack, local area network denial of service attack. Okay, and also there's a Nuke. So this Nuke is another attack which was kind of common, like more than 10 years ago, and this type of attack is targeted at a lot of Windows systems. And now the Windows systems are okay, right? Like Windows 10 is not susceptible to this type of Nuke attack. But older Windows systems like Win XP and Windows Server, Windows 2000, those older systems, they are not. They're vulnerable to I should say that they're vulnerable to this type of attack. And this attack basically, they send a TCP packet and then the URG flag in the TCP. Okay, they set the URG flag and then send it to the port 139. This actually causes an exception in uh, many Windows operating systems. And then when you do this WinNuke, it may cause the system to crash. Yeah. So that's one bug. And then these things, they can be fixed. And they are well-known attacks as well. And also there's a third example is the Christmas tree. In this example, they also target some older routers. Okay. Usually, if if you guys bought your router like within 10 years, now usually is okay. But if your router is a little old, it is then vulnerable to it could be vulnerable to Christmas tree. So this name is funny because it sets the TCP flag to 1, and then there are three fields in the TCP packet: URG, PSH, and FIN. And this is an odd combination. Okay, and then if you use packet analyzer to look at those stuff, and it looks like a Christmas tree because these three flags are set to 1, and then others thing they pretty much use dots to represent that, and it looks like a Christmas tree. So it's kind of like you have one dot in the on top, and then two dots follow that, and then three dots, so on and so forth. So it's kind of like you have a triangle shape of dots. If you view these TCP packets from for the viewer, it looks like a Christmas tree. So it's also a DOS attack. And then a lot of older routers, they have no idea. They It causes an exception. They cannot handle this situation. So it depends on the router. What will happen is unknown. It depends on the router. Some routers may be extremely slow. They just they are extremely slow. They couldn't handle. They just keep idling. So that's one case. And there's another case that I saw. If you launch a Christmas tree attack, it will cause the system to reboot after 2 minutes. After 2 minutes, okay, not immediately, but after 2 minutes. So this attack can be prevented by updating your firmware or hardware router. Okay, and there are a lot of routers on the network that are still old, because it takes time to replace all these routers. Most people, they if they can keep their job going, they can still get online. It's if you don't give them any incentives, they are not going to replace your routers. A lot of people, just if you're happy with the current stuff, for example, like you're happy with the 4G Wi-Fi, for 4G cellular network, not Wi-Fi, 4G, and do you really need to upgrade to 5G? A lot of people are, they don't want to spend that much money. So there's still a lot of older routers on the network, and that's not vulnerable. That is vulnerable to a Christmas tree. So then it will be vulnerable to this. Same apply to LAN and WinNuke. We can use traffic monitoring to uh, these tools to monitor packets. For example, like TCP dump. In the Windows versions, WinDump, I already mentioned that time. You can use that. You can download for free. It will provides information based on the packets and sniffs. Definitely, you need root access. Okay, so you have to enter your root password in order to do that. And the network interface controller, you use TCP dump. It operates in a promiscuous mode. So by promiscuous mode, for those who have learned computer networking, you will have an idea. For promiscuous mode, is a mode that receives all packets. Okay, you look at all packets. Normally, if it's not in the promiscuous mode, you only look for the packet whose target address is yourself. And for any other packet, you don't look at those. But if you can turn on the option. If you use promiscuous mode, then you actually look at all packets, okay, and look for stuff and see whether it will capture everything, okay? Not just the one whose destination address is yourself. So that you can use TCP dump to look at all traffic, all show all information, and it will produce one line output for each frame that it picks up. So it has these following these fields, timestamp, IP, and so on and so forth. Okay, and this is an example output. So this is an IP address, ARP, who's something like that. That's an example output, TCP dump. There's some other examples. So, for example, if we do a if we, let's say, a user sends to a server, the user wants to open a TCP session, then it has to do a three-way handshake. So it looks like this. So for example, this user from this address sends to this server, okay, and that's a first message, and then the server replies, okay, that's the second message, and then the third message is this, and then this is the three-way handshake. Okay, so after that they know each other, and then these examples, it shows their sequence numbers. Okay, sequence numbers, if you use TCP dump, okay, the sequence numbers can change from absolute value to a relative value. Okay, and then the port number is this. Okay, that's the one. So this is a port number. That's the port number. A server port number is 80. That's because it's HTTP. So this is another example. It shows the sequence and ACK numbers. So this is ACK1, ACK number. This is ACK568. Okay, these are the examples. TCP dump. You can use TCP dump to show all these information. Also ACK scan, and then the ACK scan, they will remove some fields to only look at ACK. So the TCP dump output, we can analyze those things. So if we know some attacks, then we can figure out a certain set of packets that could be a potential attack. So look for the signature. Okay. For example, we can ask those questions. What is source or destination IP address? Okay. So if the source looks like that, okay, then it matches something. Okay, that could launch an attack to a particular IP address. And also, what protocol? These are the basic information: source IP address, destination IP address, protocol, communication protocol, and then whether or not it is normal behavior. Okay. So, for example, normal behavior like TCP, we properly usually, I mean, the standard way is three-way handshake. Okay, something like that. If it is abnormal, if it's not three-way handshake, if something's missing, you keep sending the same message, same handshake message. So that's weird. Something like that. If it's abnormal, does it look like an actual attack? So that's T. So that's an example. That's a question we can ask. And also we can look at the signatures. For example, there's a worm, Nimda. This is an old worm that's really famous some 20 years ago, especially in the year 2001 or something. I remember that's the year that I went to the U.S. When I was studying my PhD degree. And then this worm, they kind of got this weird name, Nimda. It's actually the inverse of admin. If you look at this ADMIN, this is admin. And then the attacker somehow used this name. Okay, it sends an HTTP request like this. Okay, and then in which here the string here, this is in Unicode. Okay, and then it targets some Microsoft systems. Okay, so this worm, it will, this request will traverse the root to exploit a bug. That's a bug of my Microsoft operating system. So that's named our worm. So what's the signature? Okay, if you look at this request, okay, if you just look at the request, you may miss a variation because you can change this a little bit. So some IDS, intrusion detection system, can decode the request and see what he's doing. So for any intrusion detection systems, they have to deal with false positive, false negative. Just like our COVID vaccine, for example, or what is it called? The COVID, what's it called? COVID vaccine. So if you look at the, for example, like COVID 快筛, quick screen. There are false positive and false negatives. So that actually affects us. For example, if you do a large scale quick screen, 普筛, okay, general screen, we will, we have to look at the false positive and false negative. We know that these quick screens, they are not 100% accurate. Okay, so the problem is there are a lot of false positives. So that means a lot of people who actually who didn't get COVID, but the shows this quick screen is positive. Okay, so which is okay. I mean, this is false positive is much better than false negative. So if somebody, you do a quick screen but it gives you false negative, that's bad, because that means, okay, you are released. Okay, you go home and then you pass the COVID to other people. So the damage of COVID quick stream negative is much bigger than false positive. But the problem is, if there are too much false positives, that will actually cripple the healthcare system. So we have to really compare like what's the percentage of people who get COVID and the false positive ratio. So that is important. For example, like last year when there are only one or two cases and then there's a long period of time in during which we don't have we didn't have any confirmed case at all. So at that moment, our uh, the percentage of Taiwanese people who got COVID is so small. So maybe something like 0.2%. So that's too small. And then no matter what kind of quick screen, what kind of quick screen test you have, the false positives are maybe like 5%. So if there's a huge difference, like 5% false positive versus the total percentage of population who get COVID, if the difference is too big, like that, okay, and what happens is that you end up with getting too many false positive cases, and then those cases they will be sent to hospitals on quarantine. Now we actually they actually take a spot of the really precious medical resource. So a lot of people who have other diseases they wanted to, they really have to use those medical resource, uh, it will block them. That's a problem. So false positive that may actually cripple the entire healthcare system. So that's a problem, a huge problem. Also, it applies to our intrusion detection system. So false positive, that actually means there's an intrusion. It reports an intrusion, but there's not. So false alarm. Okay. So it occurs with generalized signature. You will always have those, and then you have to take care of those. Okay. So too many false positives may make an operator shut off a signature. It will cripple your system. Okay. False negatives, on the other hand, also generates too many alerts. Okay. I'm sorry, it fails to generate an alert. Okay. Oh, by the way, I should give you guys an example. For example, like the Tesla auto driving system. So the auto driving system, um, the sensors of a Tesla car, they are very there are cameras everywhere in the front and in the back as well. Okay, and then the first version of those, they're just too sensitive. So if anything that happens, for example, maybe a cat or something, or maybe if some wind blows a tree or something like that, it will cause the system to press the brake. Okay, so it will generate an alert, and then it will reduce the speed by pressing the brake. If there are too many false positives, then the user experience is not good because you just keep braking the Tesla car. So that is why the car manufacturer, I mean Tesla, they have to fine tune those stuff, to reduce the false positives, because there are really a lot of false positives. So that's for the drivers, for the users to feel good. However, if you turn off, they actually shut off a lot of a lot of alerts, and then some accidents happen. For example, there's a like old lady who was hit by a Tesla car, and then she just died. So that's unfortunate. So too many false positives will, you know, may lead to bad things. False negative as well. That's a different thing. So for some systems, false negatives will cause more damage than false positives. Okay, so it occurs when a signature is specific and then it fails to match a variation. Here's an example. NIMDA. So NIMDA has this. And then another example is fragmented packets. Okay, so fragmented packets. Now this is a typical system architecture of an intrusion detection system. So we have the graphic interface, because the system is usually the generated warning alert message for a human being. So they're in GUI, and then sensors will collect data. Okay, and then in between we have this management system. Management system contains algorithms, audit archive, knowledge base, and then these things. Okay, it's the key element. Okay, so the sensor is a component that provides necessary information, it collects data. So it can be called a pro or monitor, whatever. Okay, system management is the main part, the crucial part that connects everything and make them work. So it's a layer that enables communication between the sensors and other components. It is and then also algorithm, that's part of the processing engine. Okay, so this is the most difficult part, so the crucial part of an IDS. That's the algorithm. So it involves decision making, data mining, pattern matching, and these things. So for decision making, is that you already have those signatures. Okay, with that signatures, you have to generate some decisions to take actions. Okay, and data mining is you look at the past data and then you want to find patterns. Okay, and also pattern matching, that's a way to determine. So that's this part should be integrated with decision making. The deployment of sensors, usually we prefer to deploy multiple sensors so that we have some redundancy. So redundancy is important because redundancy gives us kind of like extra kind of like gives us insurance. So if something fails, the whole system will not fail because you have redundancy. So that's really important. Like error correcting codes, you actually add redundancy on the error correcting code. So if some bits get flipped, if it's not too much, then you can still recover the messages. That is really important. So it is an ability to tune the system to pick up certain kind of traffic. Okay. So many network segments exist. So sensors are paired with firewalls and packet filters. And then we also prefer to put those sensors on both sides of firewall, so inside the firewall and outside of the firewall, because the attacks can be launched anywhere. So an attacker can be within the firewall. So it's important to deploy both on both sides. And then we have to take extra care. Okay, so in the switch network, to ensure that sensor can see all the traffic, because in a switch network it's complicated. There are many directions. The data can go in and out from and to different directions. Okay. So we want to deploy separate networks or sensor communications. So that's better. That's advisable for the security and performance. Knowledge base that contains the profiles of users, systems, signatures, so on and so forth. Okay, it comes in. There are lots of different types. Audit archives store the audit files for further analysis. So it needs a lot of thought regarding how long this information must be kept, because you may constantly have data coming in. Okay, so depending on your ability, how much data you can handle, you have to keep those data for some period of time. Okay, how often it should be refreshed, these things have to be decided. Alerts, so alerts typically alert a human being. Okay, we generally it's like that. So there's a person who is in charge of this intrusion detection. So alarms are evolving to interact with sensors through the system management layer to trap intruders, divert traffic, or selectively disable access, okay, to control the access. And we have a GUI, so the operator needs to use a GUI, okay, so that makes it easy to work, okay. And a single IDS may be too weak, so we prefer, multiple IDS, preferably a network-based IDS and a host-based IDS. Okay. And so then you have redundancies. Redundant IDS, they're employed to prevent attacks. If something fails, you still have others. These are especially important. Let's think about this, for example, those big IT companies like Facebook, Google, they have a lot of servers, right? And for example, like Facebook, they're really famous. They have a large server in Sweden within a cave, and then they said they can even sustain nuclear weapon attack. So it's in the really deep inside some mountains. They actually they find a place which is located in a cave, and then Facebook put their servers there, data centers there, so that can withstand nuclear attack. Okay, and then Facebook has servers everywhere in the world, at least 10 different locations. So even if the nuclear war breaks out, your Facebook account will still be there. You can still use Facebook. So that is redundancy. Same applies to Google. Okay. Google is like that too. So redundancy should be employed to prevent any attacks if one of them fails. And the other thing is the IDS, they are themselves susceptible to attacks as well. That is why we need these things. Okay, because we can use the attackers can use tunneling of data, packet fragmentation to fool IDS. Okay, and then there's another thing called insertion and invasion attacks, and also everybody is susceptible to DOS attacks. Okay. Sequence. There are many activities ordered in time. So to detect an intrusion, it is important to note the sequential patterns as early as possible. So that includes finding maybe unrelated actions, seemingly unrelated actions by the intruder to evade the detection. Okay, so there's one way the attacker can do that by allow some time. So do something and then pause for a certain amount of time and then continue trying to intrude. So because each system have some limit about time. So after that, if it is longer than the limit, they will think that those two incidents will be regarded as unrelated. Occurrence. So intrusion occur only if it occurs. Okay, so in this sense, planning for intrusion is not an intrusion. And then the intrusion attempts should be count towards intrusion. They should be detected. Unsuccessful intrusions should be detected as well. This is a temporal mode of intrusion. So for example, if there's the bad guy called Oscar. For intruders, we use use this name Oscar. This is special. This is special to intrusion detection system. Just like in cryptography, we have Alice sending a message to Bob. Okay, and then the eavesdropper is Eve. And then the intrusion is an outsider. It's usually called Oscar. So this is bad guy Oscar. They, their initial action is this, and then they can wait a period of time, and then the next action, and then wait another period of time. The time may be different, but they may have a pattern. So we can regard this as a sequence of actions. Okay, some of the actions may be responses by the target network system. So this is this sequence is a form of attack signature. Okay. So it requires some separation of intrusion-related, intrusion-unrelated events in time. So correlating information is very, very important. Okay, it involves interpretation, combination, and analysis of information from all available sources, detecting, responding to intrusions. These are the different classes of correlation: single and multiple session, real time, after the fact, and then in-band and all-band. So in-band is we will talk about that later. It's related to the target system only. All-band is all kind of form. For example, somebody breaks in your server. That's another intrusion. So they may be correlated or not. So these are three classes of correlation. So single versus multiple session. So single session, one TCP session. It begins with a three-way handshake, ends with two fin. Okay. So we can look at those. What packets were there sent during the session? Now, these questions are important. Are they related, or are those states properly transitioned? Okay. Then we look at the series of the client-server response. So in a TCP session, that's easier. But in a UDP protocols, UDP is a sessionless protocol. It does not send out X. So it's this type of protocol is you usually use in either a smaller network or a really reliable network like fiber. So that in that case you can use UDP, okay, because it's faster. Multiple sessions, the source and destination may be different, so that's more difficult. And then the thing is, synchronization is harder. Okay. So that's a lot harder than single session. Real time, if you have to find out intrusion in real time, you have to have a lot of processing power. So the processing power is important. How much processing power you have, because it takes up resource, okay, consumes resource. The processing power is important, and also the whether or not the information is available, okay, and the human, whether or not it's available to react in real time. In the after-the-fact analysis, or post-a priori, we can use Latin, post-a-priori analysis, then there's no time limit. You can guess what might have happened and look forward. But in real time, you can't, because you have to focus on the present. Okay, it's impossible. It's impossible to guess what will happen. Okay. So if the audit trails are used, it has to be after the fact. Okay. Sometimes the incident may still be occurring as intrusion information is being processed. But in-band, all-band correlation. In-band actually means computing and networking activity is related to the target system. That's in-band. All-band is anything. For example, someone actually physically broke in the building. That's all-band. In-band components may have been spoofed. Spoof basically means the MAC address, the IP address has been tampered with. Okay, so modified. So logs may have been overwritten. Okay. The confidence level of information can be different. Intrusion response, we have passive response and active response as well. The passive response monitors traffic from the bad guy, Oscar. Yeah. Active response send this is a type of TCP packet reset packet to Oscar or terminate the TCP. Okay, so you have to take extra care. There are some trends in IDS, distributed IDS, for example. You guys can check that out. An outsourced IDS, you can outsource IDS to other companies to perform IDS for you. And IETF is the organization that actually produce TCP/IP protocol. It's Internet Engineering Task Force or something like that. There's an intrusion detection working group in IETF. Okay, so the working group there are a lot of those tools. Okay, there are many vendors you can buy. So these are the tools for Unix-based system. Okay, Cisco also has. Okay, and there are others as well. Symantec also has. Then there are also open source IDs you guys can check out. Okay. What to look for? Okay, depth of coverage. Okay, what kinds of attack? What kind of customization features? What operating system can support? And also accuracy. These are the things. Robustness. These are the things you guys can look for. Scalability, if you is one issue. Management, so on and so forth. So these are the stuff you guys can check out. The intrusion prevention comes in two kinds: IPS, rate-based, and content-based. Okay, there's some examples. Rate-based, you have this. Content-based. So that's enough for today, and then I'll see you on Thursday. So that's the only written exam. Okay, and I hope everybody can do well and enjoy the exam.